This video will cover section 8.1, adding and subtracting polynomials. So first of all, we want to talk about what a monomial is. All right, so a monomial is a number, so like 3, a variable like x, or a product of a number and variables. And it's important to know that that's a product. That means multiplication. So if we had 3 and x, it would be like 3x. And then we have a polynomial, which is a monomial or a sum of monomials. So again, that's important to see that that's not multiplying, but adding or subtracting monomials. So to help you out with that, think of like a monogamist or a polygamist. A monogamist is someone who's married to just one person, and then a polygamist is someone who's married to more than one person. So you can apply that with a monomial and a polynomial. A monomial is just one, where a polynomial is many. So each monomial, if I just have one, is called a term. So if I have a string of terms, then that's called a polynomial. All right, so for example, if I just have 5x squared y, you see there's no addition or subtraction there, so that's called a monomial, meaning one term. Then if I put in addition or subtraction, so now I have 3x minus 2, those are two different monomials that are being subtracted. So if I have 2, that's called a binomial. You can see the root word there, bi, meaning 2. So that is 2 terms. Then you can have a trinomial, which means we have 3 terms or 3 monomials that are added or subtracted together. So again, you see that root word tri, meaning 3. So what we're going to do today is we're going to be adding and subtracting polynomials together. So when you're adding polynomials, you can only add or subtract like terms. We've done this before, but really not to this extent. Because to add like terms, you're looking for terms that have the same variable product. They have to have the exact same variables and exponents. So only those can be combined. And then when we combine these, we put them in what we call standard form. And standard form is when you put them in descending powers. So if you have x squared and then an x, then you put the x squared before the x. All right, so let's see what this looks like. So for these examples, we're going to combine like terms, if possible, and then we're going to write them in descending powers. All right, so looking at part A, and I'm going to use different colors. So if you have different colors, that might help you with this today. So what I'm going to do is I'm going to use my different colors to highlight or to underline my different variables. So for instance, we're going to start off easy. We've done something like this before. So for part A, I have 5x squared is a term, and the variable there is x squared. Okay, so in order to combine that x squared, I have to look for another x squared. So the next term is negative 3x. That's not a like term, so I can't combine that. But then I see another x squared is here, so plus x squared. So those two terms that I've just circled are like terms, which I can add those together. And when I add those together, you add the coefficients and you do nothing to the exponents. So the coefficient is 5, and then this coefficient here is plus 1. So 5 plus 1 is 6, and then you leave the variable alone. You do nothing to the exponent. Okay? Then we have 3x. And 3x, the variable is x, and there is no other x variable. So that negative 3x is just going to stay negative 3x. And then finally, we have the plus 1. So the plus 1, again, there is no variable, so there's no other like terms, so we're just going to have plus 1. All right, and so that's my answer. And I want you to see that this is written in descending powers. So the x squared comes first. Then the x comes next with an exponent of 1, and then the last thing that I write is something that has no exponents or variables at all. Okay? So let's try part B, and I'm going to use my colors again. So I'm going to start off, the first term is v squared. So I'm going to look for another v squared. The next one is VW, not V squared. So it's not alike. The next one, W squared, not alike. The last one, VW, not alike. Okay, so then that's the only term that has V squared. So that's just going to stay the same. Now the next one is VW. So I'm going to use a different color. And if you don't have different colors, you can like underline for one, circle for another. So I have VW. My other VW is negative 3 VW. Now it's important here to, when you look at terms, you need to include the sign that is the plus or minus in front. Include the sign in front. So you see when I circled that 3, I included the minus. So now you have positive 2 minus 3. 2 minus 3 is negative 1. So 2 minus 3 is negative 1 VW. And I do not have to write the 1 there. Then finally, we have the VW squared, which is by itself, so there is no other like term, so plus 4W squared. And that is my answer. All right, so part C. So looking for like terms here, the first variable is a squared and then b. So I want an a squared b. The next one is a b squared. That's actually a different variable. Those are not alike. And then the last one that I have is b cubed, which again is not a like term. So you can see I have 3 different colors. So those are 3 different variables. So this is actually one of those if possible. This is not possible. So the answer is, this is already simplified. So the answer is actually just this original thing, okay? So it's already simplified because there are no like terms. That'll happen occasionally, but not very often. Okay, so for the last one, our first term is mn squared. So I want to look for another mn squared. The only other one is negative 4mn squared. Let's see if I have any other like terms. I have m squared, and then I have m squared n squared. So those 2 are different, so there's no like terms. So now when I combine them, and I'm going to do it all in one color this time, we have 6mn squared minus 4mn squared, which would be 2mn squared. Then the others, the purple and yellow, are just going to stay the same. And that is my answer. Okay, so for example 2, we're actually going to do the exact same thing, but it looks a little different. You see for part A, we have 2 different polynomials, like in parentheses, that are being added together. But if you're adding them together, all you have to do is just look for like terms, just like we did before. So I'm just going to do the same thing with my colors. And I'm going to start with the first term, which is x squared, and I'm going to look for another x squared, which doesn't happen till 3x squared. Then change colors, and my next term is negative 3xy. So where's another xy? Negative 2xy. Then my last one is going to be the y squared plus 2y squared and plus 1y squared. So now I'm going to combine like terms. So look at the colors, or look at the underlines go together, the circles go together, the squares go together. So 5x squared and 3x squared become 8x squared. So remember, you're adding the coefficients, but the exponents stay the same. You do nothing to the exponents. Then we have negative 3 and negative 2xy, which makes negative 5xy. And then finally, 2y squared plus 1y squared is plus 3y squared. Okay? I want you to pause the video, and I want you to try B by yourself. Okay, so I just did this all in one step, because you should have done this yourself. I've highlighted my like terms and then combined them. So 3 and 5x squared make 8x squared. The negative 2xy is by itself, so it does not change. And then plus y squared makes plus 2y squared. Okay, so for part C, I actually have 3 separate things, but again, it's the same thing. So I'm going to look for my like terms. Starting out, I've got 6x and positive plus x. Then I have negative 4. Now, 4 does not have a variable with it, so you're looking for other numbers without a variable. So that's going to be the 2. And then finally, the y. So I have negative 3y and positive 7y. So combining those, I have 6x plus x is 7x. Now, the next thing that I come to is the negative 4 and the 2, which is negative 2. But I want to put that at the end. So when I write these things in standard form, we put the numbers with no variables at the end. So I'm going to skip the purple for a second, and I'm going to do the green, the y's. So that's negative 3y and 7y, which makes positive 4y. And then the purple, the numbers I'm going to put at the end. Negative 4 plus 2 is negative 2. Okay, so I just wanted to talk about that and how you write in standard form. Numbers with no variables go at the end. Okay, so for example 2, we were adding variables with the parentheses. But now we're going to look at when I subtract polynomials. So in order to subtract polynomials, if you look at part A, I've got these 2 parentheses with a negative in between. So what you're going to do is you have to have another step before you can find the answer. So what you want to do is to change the sign of each term in the polynomial to be subtracted, which comes after the subtraction sign. Then you add the terms. So for part A, you see I have no subtraction in front of the first parentheses. So I'm just going to rewrite those terms. They did nothing. There was no change. Then this minus sign right here, that actually, think of it as like distributing a negative 1 to each term inside. So that's going to change the sign of everything inside. So 3x squared becomes negative 3x squared. Negative 2xy becomes positive 2xy. And positive y squared becomes negative y squared. Once you do that, now it's the same exact thing that we've been doing. So look for your like terms. 5x squared and negative 3x squared, negative 3xy and positive 2xy, and positive 2y squared, negative y squared. And then just simply combine like terms. 5 minus 3 makes 2x squared. Negative 3 plus 2 makes negative 1xy. Positive 2 minus 1 is positive 1y squared. And that is my answer. Okay? So now what I want you to try is B by yourself. Again, I want you to pause the video, do the same thing that I did in A by yourself in B. Okay, before I write my final answer, I'm just going to show you what I did. The first thing I did was take this negative here and change each of those signs. So that's a negative 4a, positive 2b, positive c, and negative 1. Then I found my like terms. So I actually have 4 different like terms this time. So now to combine them, negative 2 and negative 4 make negative 6a. 3b and 2b make 5b. Negative 5c plus 1c is negative 4c. And then 2 minus 1 is a positive 1. And that is my answer. Okay, so for the very last one, we actually have 3 different polynomials because you see 3 sets of parentheses. So look in front of each parentheses and see if there's a negative sign. So you see that there's the negative right here. So that one we're going to have to change the sign inside that parentheses. So I'm going to first rewrite every term. The first parentheses doesn't change. The second parentheses is going to change signs, so negative x and negative 1. The last parentheses is just a plus, so it does not change sign. So now, let's look for our like terms. We have 4x squared and plus x squared, 3x minus x and minus 5x. This is the first time that we actually have three like terms. So make sure you look at every single term to make sure that you've gotten every number. And then we have another of three like terms. So we have -7, -1, and +2. So make sure you get everything. That's why I like to put underlined circles and squares. So if I left anything out that didn't have something, I know that I forgot. All right, so now the 4x squared plus x squared is 5x squared. 3x minus 1x is 2x. Then 2x minus 5x is -3x. Again, you're adding three different things together. 3 minus 1 is 2. 2 minus 5 is -3. Then -7 minus 1 is -8. -8 plus 2 is -6. And this, again, just to remind you, is written in descending order because you have an x squared, then an x to the first power, and then no x at the end. So that's it. That's how you add and subtract polynomials.